Go outside tonight if you can. Step away from the city lights if possible. Look up. Take a moment to really see what's there. If the sky is clear, and even if it's not perfectly clear, you'll likely see the moon. Our silent, glowing neighbor, hanging there in the vastness, a constant companion. Whether it's a full disk, blazing with reflected sunlight, or a delicate crescent, barely visible, you're always seeing the same face, the same familiar features, the same craters, pockmarking the surface, silent witnesses to cosmic impacts. The same dark plains, the Lunar Maria, ancient seas of cooled lava, the same features that have greeted every human in history, from our earliest ancestors to the astronauts who walked upon its surface. This isn't just a poetic coincidence, a quirk of perspective. It's a cosmic clue, a subtle hint about the forces at play in our universe. The Earth spins on its axis, the moon orbits our planet, everything in space is in constant motion, a grand celestial ballet. So why, amidst all this movement, do we always see the same side of the moon? The answer isn't that the moon doesn't spin at all. It does rotate on its axis just like the Earth. The truth is far more fascinating and reveals a deep connection between the Earth and its only natural satellite. The moon's rotation and its orbit around the Earth are perfectly synchronized, locked in a gravitational embrace. The features you see have names, bestowed upon them by astronomers throughout history. Mare Tranquillitatis, the Sea of Tranquility, where humans first walked on another world. Oceanus Procellarum, the Ocean of Storms, the largest of the Lunar Maria. Remnants of ancient volcanic activity, frozen in time on the lunar surface. The bright highlands, heavily cratered and ancient, stand in stark contrast. And dark Maria, smooth plains formed by ancient lava flows, form patterns that cultures have interpreted for millennia, weaving stories and myths around the lunar face. This unchanging face is a breadcrumb, a subtle clue left by the universe, pointing us toward a deeper understanding of gravity, the force that shapes the cosmos. It's not a random fluke, a mere coincidence in the vastness of space, but the result of a powerful, invisible force acting over billions of years. The moon's static portrait, its unchanging face, is a sign of a dynamic past, a history etched in stone. A gravitational tug-of-war, a cosmic dance between two celestial bodies. That ended in perfect balance, a synchronized equilibrium that continues to this day. The reason we only ever see one side of the moon, the near side, is a consequence of a beautiful synchronized dance, a testament to the power of gravity. Choreographed by gravity itself, this cosmic dance has shaped the moon and its relationship with Earth. Understanding this dance, this delicate balance of forces, reveals something fundamental about the workings of the universe, a cosmic revelation, about how our corner of the cosmos works, and the intricate relationships between celestial bodies. Every person, in every culture, across the globe, across all of recorded history, and even before, has seen the exact same features on the moon, the same familiar face, staring back at them from the lunar surface, a silent witness to human history. It's a universal constant in the human experience, a shared connection to the cosmos. The man in the moon, a familiar figure in Western cultures, the rabbit, a common interpretation in East Asian traditions, or whatever shape your culture sees in the patterns of light and shadow, is a permanent fixture in our night sky, a constant presence. This is the story of why the moon always shows us the same face, a tale of gravitational forces and cosmic synchronicity. And it all starts with gravity, the invisible hand that shapes the universe. With all the spinning and circling in space, the constant motion of celestial bodies, shouldn't we eventually see the moon's entire surface? Shouldn't its rotation reveal all its secrets to us over time? Imagine a friend walking in a circle around you. To always see their face, they'd have to turn perfectly in sync with their movement. It would require a deliberate, coordinated effort. For the moon to do this naturally, to perpetually show us only one side, seems like an astronomical coincidence, a truly remarkable alignment. But the universe doesn't do coincidences on this scale, not when it comes to fundamental behaviors. When something looks too perfect, too precisely orchestrated, it's usually a sign of a powerful physical law at play, a hidden mechanism governing the cosmos. Nature seeks stability, it strives for equilibrium. The moon's behavior is a prime example of this natural tendency. The Earth and moon are gravitational partners, locked in a cosmic dance, influencing each other profoundly. Their fates are intertwined. The moon pulls on our oceans, creating tides, a daily reminder of their connection. But what does Earth's gravity do to the moon? How does our planet affect its celestial companion? This isn't unique. Many moons in our solar system are tidally locked to their planets. It's a common phenomenon. Jupiter's Galilean moons, Pluto and Charon, they all show the same face to their parent bodies, a constant, unwavering gaze. This pattern tells us we've found a universal process, a fundamental aspect of how gravity shapes the cosmos. Gravity at work over immense timescales. A slow, patient sculptor of the universe. The force responsible is gravity, but not just a simple pull. It's more nuanced than that. It's a differential pull. A gradient of gravitational force. The side of the moon closer to Earth feels a stronger tug than the far side. A subtle but persistent difference. Over billions of years, across the vast expanse of geological time, this tiny difference drove the moon into its current synchronized state. A testament to the power of time and gravity. It's a story of a gravitational conversation, a delicate balance of forces that has lasted for 4.5 billion years. A cosmic dialogue etched in the fabric of space-time. The moon's locked face is not a fluke, not a random occurrence. It's the inevitable outcome of physics, the predictable result of natural laws. The universe prefers harmony. It tends towards order and balance. The moon's unchanging face is proof of this cosmic preference, and it all comes down to tidal forces, the subtle, persistent hand of gravity shaping the cosmos. Gravity exerts its influence on every part of the moon, a constant and unwavering force. However, the gravitational pull isn't uniform. It pulls with greater intensity on the side of the moon that directly faces Earth. This difference in gravitational force is key to understanding tidal locking. This difference in gravitational attraction is precisely what we call a tidal force, the very same force that is responsible for the rhythmic rise and fall of Earth's ocean tides. It's a fundamental aspect of celestial mechanics. Now, the moon isn't a perfectly rigid sphere. Earth's relentless gravity stretches it ever so slightly, creating two subtle bulges on opposing sides of the moon. These tidal bulges, though subtle, act as handles, providing a point of contact for Earth's gravity to grab onto. Imagine a scenario where the moon spins either faster or slower than its orbital pace around the Earth. In this case, the bulges become misaligned with Earth, and Earth's gravity exerts a tugging force on them, effectively creating a torque, a twisting force. This torque functions much like a brake, gradually slowing down or speeding up the moon's rotation until its spin perfectly synchronizes with its orbital motion. The ultimate result of this process is what we call tidal locking, where the moon's rotation period becomes precisely equal to its orbital period around the Earth. In its early days, the moon was much hotter and more pliable, and it shed rotational energy in the form of heat through this very process of tidal interaction. As time passed, the moon's spin gradually decelerated, and eventually it became tidally locked, much like a hard-boiled egg spinning in perfect synchronization within its orbit. This phenomenon represents a gravitational handshake, a constant interaction that ensures one lunar face is perpetually turned towards our planet. Tidal locking is, in essence, nature's elegant solution for achieving a state of gravitational balance and equilibrium. Billions of years ago, the moon spun much faster and was closer to Earth. Back then, you could have seen the entire lunar surface from Earth in a single day. But the moon's rapid spin created a conflict. Its tidal bulges were dragged ahead of the Earth-Moon line. Earth's gravity pulled back on these bulges, acting as a brake. This slow, relentless tug converted the moon's spin energy into heat, gradually slowing its rotation. As the moon's spin slowed, its day grew longer, and it drifted farther from Earth. After millions of years, the moon's rotation matched its orbit. The tidal bulges aligned with Earth, and the braking stopped. The moon settled into its most stable state, tidally locked, always showing us the same face. This process is still happening, but now the moon's face is fixed. Earth tamed the moon's spin with gravity and time. The result is the familiar lunar face we see today. Many think the moon doesn't rotate, but that's a misconception. The moon spins on its axis. It just does so in perfect sync with its orbit around Earth. Imagine standing in the center of a room as a friend walks in a circle around you, always facing you. To do this, your friend must turn as they walk, completing one rotation for every orbit. That's exactly what the moon does. From Earth, we always see the same side, but from space, the moon completes a full spin each orbit. This is synchronous rotation, the essence of tidal locking. The moon's day and year are both about 27.3 Earth days. It's a cosmic dance, choreographed by gravity. So, the moon spins, but in perfect harmony with its journey around us. The illusion of stillness is actually a demonstration of elegant physics. The moon's rotation is a hidden motion, revealed by understanding its orbit. One side of the moon always faces us, the other, the far side, always faces away, For millennia, the far side was a complete mystery. No human had ever seen it. The term dark side is a misnomer. The far side gets just as much sunlight as the near side. The real mystery was its geology. Would it look like the side we know? The Earth's presence may have shielded the near side from impacts, and the far side's crust is thicker, making it different. The far side was uncharted territory, a blank map waiting for exploration. For centuries, we could only wonder what lay beyond the familiar lunar horizon. The far side became a symbol of the unknown, fueling curiosity and imagination. It was the last great geographical mystery in our cosmic neighborhood. In 1959, the Soviet Lunar 3 probe became the first to photograph the moon's far side. Using film and primitive technology, Lunar 3 captured grainy images and sent them back to Earth. For the first time, humanity saw the hidden hemisphere. The images revealed a landscape dramatically different from the near side. Almost no large maria, just rugged, cratered highlands. The far side looked older, more battered, shaped by a thicker crust that prevented lava flows. Lunar 3's photos proved the two hemispheres were geologically distinct. It was a landmark moment. The blank map was finally being filled in. The far side's secrets began to emerge, thanks to human ingenuity. This mission marked the beginning of our true understanding of the moon as a complete world. The far side was no longer a mystery. It was a new frontier. Lunar 3's success inspired generations of lunar exploration. The moon's hidden face was finally revealed. Since Lunar 3, robotic explorers have mapped the far side in stunning detail. Probes like NASA's Lunar Reconnaissance Orbiter have revealed every crater and basin. We now know the far side's topography better than some parts of Earth. But for us on Earth, the view remains unchanged. Tidal locking keeps the far side hidden. Only astronauts who've orbited the moon, starting with Apollo 8, have seen it with their own eyes. For them, passing behind the moon meant losing contact with Earth and witnessing a stark, untouched landscape. In 2019, China's Chang'e 4 landed a rover on the far side, beginning surface exploration. Future missions may send more astronauts to explore these regions. Until then, the far side is a frontier we visit only through our robotic and human emissaries. The moon still holds mysteries, just out of sight. Exploration continues, pushing the boundaries of what we know. The next time you look at the moon, remember the ancient story it tells. Its steady face is the result of billions of years of gravitational dialogue. The moon's locked rotation is a lesson in how the universe seeks stability. This cosmic lockstep means everyone on Earth sees the same lunar face, a shared human experience. The far side, once a mystery, now symbolizes exploration and curiosity. To truly understand, we had to change our perspective, sending probes and astronauts to see what lay beyond. The moon's story is still being written, with new missions and discoveries ahead. Stay curious. The universe is full of elegant solutions and hidden stories. The moon's unchanging face is just one chapter in the grand cosmic narrative. Ask questions, seek answers. The simple act of wondering about the moon can lead to incredible journeys through science and history. The cosmos is waiting to be discovered. And it all starts with looking up.